All right, welcome to page 4 of the notes. And so this next two, not too bad. We're going to evaluate the integral of y squared dv, where e is the solid hemisphere, x squared plus y squared plus c squared. So we're basically just working on, a semicircle that's cut on the y, where y is greater than 0. So all of our positive y values. And so if we look at this, I'm just going to quickly draw this. All right, that's not perfect, but basically that circle. All right, and then it goes, of course, also on the x and y. So we're just doing that part of a sphere, and so I'm going to use all this information to help me out setting up everything. So of course I'm going to do phi as the for outside integral. So phi is going to be 0 to pi. All right, we're going, that whole distance along the z-axis. Theta, we're going from positive x to the negative x-axis, so that's going to be from 0 to pi as well. And then our phi is going to be from 0 to 3. It's going to be our radius. Y squared, so the inside of the integral is just going to be our y squared, so rho squared times sine phi squared times sine of theta squared. And this is going to be times rho squared sine phi d rho d theta d phi. And again, in this case, it doesn't matter because they're both integrals from 0 to pi are the same. Well, I noticed one thing. This is all multiplication, so I can break these all up into their own integrals and multiply. So it looks like I'm going to have the integral from 0 to pi, and we'll start off with our, we could do sine squared theta. D theta times 0 to pi sine cubed phi d phi, and then times 0 to 3, the integral from 0 to 3, rho to the fourth, d rho. All right, now change what we can or change what we must. And so this first one, we're going to change that interval from 0 to pi to 1/2 1 minus cosine 2 theta d theta. And 0 to pi, it's sine cubed, so sine squared times sine. So that's going to be 1 minus cosine squared theta, just like sine phi times sine phi d phi. And then, that's just going to stay the same. Rho to the fourth. What was that for? D rho. All right. Now let's go ahead and multiply, or not multiply, but integrate. So I'm going to have the 1/2. I'm going to keep that 1/2 on the outside. And I'm going to have rho minus, plus 1/2 sine of 2 theta from 0 to pi times sine theta is going to be negative cosine theta. And then I have cosine theta, integral of that's going to be negative sine theta, so plus sine theta. So again, 1/3 cosine cubed phi, not theta, minus cosine phi from 0 to pi. And then times 0 to 3, so rho, so 1/5 rho to the 5th. Alright, now let's go ahead and substitute in what we can. Alright, so plugging in for rho, we get 1/2 rho, and then 1/2 sine 2, pi. So looks like we're going to get 1/2 times pi plus sine of 2 pi is 0, so that goes away, 0. So that's just going to be times 1/2 pi times, all right, plug in the pi, so we're going to, looks like we're going to have 1/3 minus, whoa, that should be negative 1/3. Let's see. Plug in pi, so it's going to be negative 1/3 minus cosine, so that's going to be plus 1. Yeah. Plus 1. And then minus. And then we have, I'll just plug that in, 0, so 1/3 minus 1. So it looks like we're going to have 2/3 plus 2/3 there. And then for the last one, is just going to have 243 over 5. And multiplying through, we're going to get 162 pi over 5. All right, that does it for 24. 36, use cylindrical or spherical coordinates, whichever seems more appropriate. And we want to find the volume of a smaller wedge cut from a sphere of radius A by two planes that intersect along a diameter at an angle of pi over 6. So I'm going to go ahead and just draw what that represents. And so basically what we're doing we're cutting this. I'm going to, we have a sphere. So I say, okay, this is a 3-dimensional sphere. We're going to see if I can make that a little bit better. All right, good. I'm going to try to color the inside of that. All right. So say we have a 3-dimensional sphere, and we're going to cut two planes that intersect along a diameter at an angle of pi over 6. So the angle between these two planes that we're going to cut, so we'll cut this piece, and then we'll cut this piece, and that's going to be a distance of pi over 6. And so, I'll just draw it on top too. And we're cutting that all the way through. So then what's going to look like is we're just going to have this wedge like so. Of this circle. Alright, where the distance, or this little distance right here, is pi over 6. Alright, and so since I'm dealing with a circle, obvious sphere is going to be spherical coordinates is what I'm going to use. And so we're going to go ahead and set that up. So we'll set it up using again, phi first. Well, that's a whole, that's the whole half of a circle. So that's going to be that z. Again, if we made, say this was the positive z-axis, that's going to be a whole semicircle. So that's just going to be from 0 to pi. Then we're going to have the integral from 0 to pi over 6 for theta, because that's the distance we're going from. And then we have a radius of a, so it's just going to be from 0 to a. And then we're going to use our spherical coordinates, so rho squared. Again, we're not given a function, so we just do dv, so rho squared. Again, we're just finding volume as well. Rho squared times sine phi d rho d theta d phi. And now I can just break this up into all their own integrals. So we're going from 0 to pi sine phi d phi times 0 to pi over 6 rho, so d theta, and then rho 0 to a, it looks like a 9, 0 to a rho squared d rho. All right, we'll integrate, so negative cosine theta 0 to pi times times 0 to theta pi over 6 to 0, and then rho squared is just going to be 1/3 rho cubed 0 to a. Go ahead and plug in. This is going to give us negative cosine pi is 1, and then so minus 1, so that's just going to give us 2 times, that's just going to give us pi over 6, and then it's just going to give us 8 cubed over 3. Multiply all that through, and we're just going to get 2 pi a cubed. I can get rid of that 2. So it looks like we're just going to get pi a cubed over 9.